Greetings, Spartan fans. Today we are going to talk about conic sections. More importantly, we're going to talk specifically about ellipses. Okay, so first, what on earth is a conic section? So we talked yesterday, or whatever day it was I saw you last, about circles. So a conic section is what happens when you have two right cylindrical cones. I know you thought your geometry days were over, but they're not. So you have two right cylindrical cones, and they are stacked on top of each other. So you've got a cone, its vertex is, it's right side up, and then you've got an upside down cone, and they meet at the vertex. And each one of these cones, it has a special fancy name called a nape. And a conic section is what happens when you take a plane. So there are four conic sections here. You've got a plane, and the plane could intersect horizontally, and that's a circle. So this first picture here is a circle, which we talked about yesterday. And then the second one, which we're going to talk about today, is an ellipse. An ellipse is what happens when the plane is tilted slightly, so it has this ovular shape, and that's known as an ellipse. You could also have the plane which is tilted such that it intersects the plane at a diagonal. The plane intersects the cone in a diagonal, and that's a parabola, which you've talked about and we'll do more of. And then you have where the plane could actually intersect both cones, i.e. napes, in two places, and that's called a hyperbola. I like to think of it as a hyperparabola. There are two of them. So we're going to talk about those later. So the first one is a circle, and then this next one is an ellipse. And an ellipse is a fancy way of saying it's an oval. And then we have a parabola, and then this last one is called a hyperbola, and it's essentially two parabolas going in opposite directions. Okay, so today we're going to look at the ellipse. And an ellipse is what's created. It's the collection of all points in the plane such that we have the distances from two fixed points known as the foci. Foci is the plural of focus. So foci create an ellipse. So what I want you to do is imagine you have these two fixed points and you have thumbtacks and you have a piece of string and it's attached by these thumbtacks. And if you have the string and it's pulled tightly, and here's my pencil with my string, and I pull the string all the way around, what is created is an ellipse. And an ellipse could be vertical or an ellipse could be horizontal. So you don't have to copy down these pictures in your notes. You can clearly see that I cut and pasted something so I could give you a better picture of what these look like. Okay, so the ellipse has an X radius and a Y radius. Okay, and I apologize now. All that noise in the background is my bulldog trying to beg for food. What can I do? So we have x minus h, and you should recognize x minus h squared from when we did circles. And we have y minus k squared. Again, that's a circle. But for a circle, it was equal to r squared. And we're going to change that now because an ellipse they're not equidistant from their center. What we're going to do instead is we're going to call this A and B. And we're going to have it equal to 1. So instead of r squared, it's going to equal to 1. And by definition, it must equal 1. Okay. When A is greater than B, the ellipse is horizontal. So that would look like this first picture. That would be a horizontal ellipse. Okay. And so this is horizontal. It opens what I call in the x direction. And if B is greater than A, you guessed it, it's going to be a vertical ellipse. Okay. All right, so instead of using A and B, I tend to use R sub X and R sub Y. I think there's too many variables as it is. So I'm going to call this R sub X. And that way it doesn't matter what's A, what's B, who cares? the x radius, the y radius. Okay. Everything happens from the center of the ellipse. So if I have a center, I'm going to move right and left from the center, the x radius, and I'm going to move up and down the y radius. And we're going to talk about these foci in a minute. The vertices of this ellipse lie on what we call the major axis. And the major axis is going to be either parallel to x or parallel to y. And we'll do an example. And the co-vertices lie on what we call the minor axis. And that's going to be parallel to x or y. So in a horizontal ellipse, the major axis is going to be x. And in a vertical ellipse, the major axis is going to be y. So you're either major or you're minor, and you're either parallel to x or you're parallel to y. So in this first picture, x is the major axis, and y would be minor. And then in the vertical parabola, y would be major, parallel to y would be major, and parallel to x would be minor. All right, and so we have these vertices. And so in this first picture, the co-vertices, I'll draw them in a different color. The co-vertices would be the end point, so to speak, of the top and the bottom. That would be a co-vertex, co-vertice. Important, but not as important as the vertex. And we'll talk about the foci in just a minute. So I think what'll be easiest is if I just work through a problem with you and we identify, and as we graph it, I think that'll make things a little bit easier. Okay, so let's start with a problem such as, one sec, sorry about that. Here we go. So let's look at x squared plus 4y squared plus 10x plus 24y plus 45 equals 0. All right. So I can tell you right away that this is not a circle. And the reason why it's not a circle is because the coefficient on x squared is 1 and the coefficient on y squared is 4, and those are not the same. So I can't have one radius. I'm going to have several different, I'm going to have a y radius and an x radius. Okay, so I wasn't kidding when I told you that you have to know how to complete the square. So I'm going to have x squared plus 10x, leave space. Factor out the 4, a must be 1 to complete the square. Okay. All right, so we're going to take half of 10 and square it, and that's going to be 25. I forgot the plus sign here. And I'm going to take half of 6, and I'm going to square that, and that's going to be 9. You did not add 9. We really added 36, 4 times 9. And now we're going to factor, and that's going to give us the center. So this is going to be x plus 5 squared plus 4 times y plus 3 squared equals, let's see, how about, I've got my handy dandy calculator here. Negative 45 plus 25 plus 36, 16. Okay. And now to put it in general form, I need to divide both sides by 16. Okay. So I'm going to write this as, two ways you can write it. You can write it as x plus 5 squared over 16, or if you prefer, you can write it as x plus 5 over 4 squared. Either way is okay. I don't care which way you write it. I tend to write it the second way, whatever. Plus y plus 3 squared over 4 16ths is a fourth, and that's going to equal to 1. So the alternative is to write it as y plus 3 over 2 squared equals 1. Okay, my x radius is 4. That comes from the denominator. And my y radius is 2. Okay, last time I checked, 4 was greater than 2. Okay, so therefore, this is going to be a horizontal ellipse. It is going to be wider than it is tall. And the center of this ellipse is at -5, -3. All right. Okay, so we're going to draw a nice graph. And we're going to make sure we have everything labeled. So the center is at -5, -3. 1, 2, 3, 4, 5, 1, 2, 3. Okay, so here's my center. Okay, from the center, I'm going to move right and left 4. So I'm going to move right 4 and left 4. And those are my vertices. So it's going to be, how about -1, -3, and let's see, left 4, -9, -3. Those are my vertices, and they need to be labeled as such. You can't just say points. They are specifically called vertices. Now in my y direction, okay, so my y radius was 2. So from my center, I'm going to move up and down 2. And those are going to be called my covertices. -5, -1, I want to say, I hope. And how about -5, -5? Okay, and I'm going to draw this ellipse. Okay, not good enough. Now we have to worry about these things called the foci. The foci are always inside of the ellipse, always. So my foci, and they always lie on the major axis. So here's my major axis. It's parallel to x. The foci always lie on the major axis. So how am I going to figure out these foci? Okay, so the book uses A and B, and it's always really confusing. When do I add? When do I subtract? So I'm going to stick with the x radius minus the y radius. It is always, always, always the major radius squared minus the minor radius squared. And that's going to equal to c squared. And c is the focal distance. It's got to be the major minus the minor because the major is bigger. The major is bigger. So if you take a bigger number and you subtract a smaller number, you're going to get a positive. If you flip it around, if you do a small number minus a big number, it's negative, and you can't square root a negative. So in this particular problem, it is going to be the x radius squared minus the y radius squared, and that's going to equal to c squared. Okay, so my major radius was 4, so that's going to be 4 squared, minus my minor radius was 2, and that's going to equal c squared. So that's what, 16 minus 4, which is 12. Always, always, always simplify radicals. Oops. So the c is going to be 2 root 3. So from the center, from the center, from the center, everything happens from the center, whether it's an ellipse or a circle, or when we talk about hyperbolas the next time I see you. So from my center, did I mention it's from the center? Here we are. I'm going to move 2 root 3 to the right. and I'm going to move 2 root 3 to the left. I have no idea how much that is, but you better make sure that you are inside of the ellipse. Let's see, 2 root 3. How much did I say that was? Square root of 12. So between a little bit more than 3. I don't know. 1, 2-ish. Good enough. Oh, I hate when it does that. 1, 2, 3. Okay? And they have points. And do not give me any decimals. It's not okay. So, for my center point, the x value of my center was how much? -5. -5 plus or minus 2 root 3, comma, -3, I want to say, yeah. And there you have your foci. All right, so every ellipse. Okay. I don't know what just happened here, but I'm frozen. I can't move the screen.